Welcome back. What we are now going to look at is multiplying with these radicals. And the good news is this is going to go very similar to polynomials. And in fact, we can even use the box to organize this craziness. So that is what I'm going to do. And these are also possibly a little uglier than what you might see in ALEKS. But I figure if I show you uglier here and it's not as ugly in your homework, you should be equipped to handle it. All right, so these we are going to distribute. I have some addition and subtraction inside these, and then I have a term being multiplied outside. So this is going to be a distribution. Now, because it's only one term outside, I'm not going to draw the box. So I'm just going to draw the pairs instead. And hopefully that makes sense, but you'll see. All right, so that is 3 square root of 6 times 2 square roots of 6. I can already see I need more space. Yay for the magic of technology. Plus 3 square roots of 6 times 3 square roots of 3 minus, I really write too big, 3 square roots of 6 times 1. All right. So the times 1 here isn't doing anything, but that minus sign does change the sign. All right, let's see what's going on. So up front here, I got 3 and 2. This is all a bunch of products. So I'm just going to rearrange to get the stuff that goes together. 3 times 2 on the outside is 6, and the square root of 6 times the square root of 6. That would be a pair of 6's under the radical, which equals a 6 outside the radical. That is a ridiculous dot. All right, so just to be clear, that 6 is coming from there. This 6 is coming from those two. Probably should have picked a problem where it wasn't 6's everywhere. Now here I got 3 times 3 on the outside is a 9. And then 6 times 3 is 18. Now we are going to have to check that and see if it reduces, and it does reduce more, but the 6 times 6, they were already the same. So that's why I kind of jumped the gun there and just went ahead and wrote it. And then minus 3 square roots of 6. All right, so I have now a number, a 18 that's going to be reduced, and a square root of 6. So the 18, that is 9 times 2. So we got a pair of 3's. So first here, 36 plus the 9 from the original problem times 3's coming out, left over square root of 2 minus 3 square roots of 6. So all we got to do is clean up the 9 times 3, and that's all she wrote. These are not like terms, but in the original, they were not like terms. Unless we were multiplying more than one term times more than one term, 2 or more times 2 or more, they usually are not going to combine anymore. Sometimes you might get like 2 things that work out to honestly, no, they don't. They usually don't go together more. So I have 36 as a number plus 27 square roots of 2 minus 3 square roots of 6. And that's all she wrote. That is our simplified answer. So we did the multiplication, and then the simplify was reduce the square root of 18 to the square root of 2 with 3 on the outside. All right, B, a little more interesting because I threw some variables in there. But same song, second verse, except this one, since the binomial times a binomial, you could use FOIL. I'm going to go ahead and use the box method again. I just like the way it organizes the information. All right, so one of them across the top. So here I'll put 2 square root of x minus 3, and then down the side, 3 square roots of x, all the things multiplied as a term. And then keep that minus with the 5, so you remember you're multiplying a negative. So 2 terms by 2 terms is 2 rows and 2 columns. There we go. All right, now we're just going to multiply. So I could write it like the pairs I did before over here, like the 3 square root of 6 times 3 square root of 3. But since I already have a top and side and we're used to the way this box works, 3 times 2 is 6. And then I will just write the square root of x squared. I usually don't like getting into reducing radicals in here because it gets messy. It's too many things to write. So I will take care of that when I write it out outside. 3 square roots of x times negative 3, negative 9 square roots of x. Then negative 5 times 2 square roots of x, negative 10 square roots of x. And negative 5 times negative 3 is a positive 15. So I can definitely clean up the first term I wrote, and we have like radicals. So when you do the binomial multiplication, this does happen. It's actually pretty normal for it to happen. Now the square root of x squared, square root square cancel out, so it's just x. All right. So that first term is going to be 6x. Now, what we like to do is write radicals as far to the end as possible, and that is to avoid typos when typing it in and writing typos. So accidentally extending the square root too far can make your answer look different than you meant. So that's one of the reasons why we have that as like a rough, vague math grammar rule that you don't technically have to do, especially now that we type more, but still. So negative 10 square roots of x minus 9 square roots of x is just more negative 19, but still the square root of x. So we've combined like terms, cleaned up, simplified, reduced terms, and that's it. So which term looks more simplified? It's more about what are we doing next. So it might be, if this was an equation, then multiplying those all out, now I have 3 terms that I could move across the equal sign, add or subtract to the other side. We will later on see some equations with radicals where we solve this kind of craziness, so be forewarned. Now the whole point of this, all of this was leading up to the use of conjugates. So remember when I talked about a difference of squares and how it factors beautifully and they interact nicely? The interaction there is what is so useful here. So we're going to multiply these and then we're going to take a look at the results and you guys will see why this is useful mathematically, at least by hand. All right, so since these are binomials, again, I will use the box method. I like my organization. So we have 4 plus the square root of 7 and 4 minus the square root of 7. Now, certainly, if you actually actively recognize that this is a difference of squares, you can kind of skip the box and write what the result would be. But if you don't recognize it, I will show you what happens. So the 4 times 4 is going to be 16. Then I have positive 4 square roots of 7. And then down here, I now have negative 4 square roots of 7. Aha! The outsides and the insides. Yes, we're supposed to see opposite terms that will cancel out. And then the last is going to be negative square root of 7 times square root of 7. Same number, so it breaks out as a pair. It's just number 7. So I have ugly radical thingy, and I multiply it out. Those guys cancel, and what is left is just numbers. 16 minus 7, which is 9. So I just discovered that 4 plus the square root of 7 times 4 minus the square root of 7 is the same as the integer 9. That is a very disgusting way of writing 9. But the interesting thing will be how we can use this to rationalize. So let's take a look at B. Let's see what happens there, because this is even crazier. All right, so let's start out right now. 2 square roots of 5x plus 3 2 square roots of 5x minus 3. All right. So this first one, I've got outsides and insides. The outside 2 times 2 will be 4. Then inside the radical would be 5x times 5x. Since they are the same, the radical will cancel out and it's just going to be 4 times 5x. So I'm going to leave it like that. When I pull it out, I'll probably clean it up more. Now here, 3 interacts just with the 2. So we have plus 6 square roots of 5x. And then down here, minus 6 square roots of 5x. Yay, canceling. Negative 3 times positive 3 is negative 9. So again, cancel. And then we just clean up. 4 times 5x is 20x's minus 9. So here they do not interact further. I can't combine those anymore, but what is gone from the answers? There are no more radicals. Yep. That is the whole point of multiplying by a conjugate. What the difference of squares gives us is the ability to pick a thing that I can multiply into this that creates a cancellation where the square roots are no longer on the bottom. The reason we do this is dividing by a square root by hand is difficult. That's why we're going to talk about rationalization in the next video. So doing something like 1 divided by the square root of 2. So if you're going to do it by hand, you've got the 1.414 into 1. No one wants to think through that. So when we rationalize, now the ugly decimal is inside the division, and we have an integer outside the division. That I can do. It's a lot more straightforward. So that is why we rationalize. It's because we didn't have handheld button calculators. All right, see you in the next one.